In this video, we are going to continue with section 1.8 and the composition of functions. But in particular, this video is going to focus on decomposing functions. What do I mean by that? Let's say that you're given a function, f of x, and let's say its formula is given to you. Here it's going to be 12 times ln of x cubed plus 1. The goal is going to be to find two functions, g and h, so that the function can be written as, the original function I mean, as g composed with h. And so this here is the decomposition. We're taking the function f and decomposing it into two others. Okay, so we need to find two functions, g and h. How are we going to do that? Well, you have to remember, what does it mean to compose two functions? It means take one and plug it into another. So we need to find something that's getting plugged into something else. Well, notice here, x cubed plus 1 is getting plugged into ln. But there's a times 12. So it looks like x cubed plus 1 is getting plugged into the function 12 times ln x. So let's write here, let's try this, g of x, let's let that be 12 ln x. Let's let h be the function x cubed plus 1. Now notice that when you compose these two functions, g, circle, h, you get, well, you take x, you plug it into h, that gives you x cubed plus 1. But then you take x cubed plus 1 and plug it into g. That's just 12 ln. And so what is that? That's just the original function, f of x. And so these two functions works as a decomposition of f. Alright, is that the only one? Well, maybe someone else saw it different. Maybe someone saw x cubed plus 1, the ln of that, maybe someone saw that as getting plugged into the function 12x. So maybe someone else may have written g of x equals 12x, and h of x to be ln of x cubed plus 1. And so now, when you look at their composition, g circle h, what do you get? Well, ln of x cubed plus 1, that's h of x, that's going to get plugged into g. So you have ln of x cubed plus 1, and that's getting plugged into g of x. But g of x just says multiply what you plug in by 12. Well, what is that? That's just, yet again, the original function f. And so this decomposition also works. Now, there are actually other ways of seeing it. And in fact, it's not that you can only decompose functions into two functions. You could decompose it into more than two. The reason for that is simple, because the functions that are getting composed might actually be able to be further decomposed. So x cubed plus 1, for instance, that is a composition of functions. It's x getting plugged into the function x cubed, which in turn is getting plugged into the function x plus 1. And so, let's just write that out one more time. Let's let g of x be something like 12x, just like we had in the previous example. We're going to let h of x be the same exact thing, ln of x cubed plus 1. Oh, ln of x, right. So not the same thing. But k of x, let's make that x plus 1. And L of x, that's yet another function. Let's make that x cubed. So look what happens here. Without writing anything down, let's take x cubed, plug it into k of x. That's going to give us x cubed plus 1. But now x cubed plus 1, let's plug that into ln of x. That's going to give us ln of x cubed plus 1. And then finally, let's plug that into g. And we get 12 times ln of x cubed plus 1. But again, that's just f. And so at the end of the day, we get that f is equal to the composition of g with h with k with l. So you see, it doesn't have to be two functions all the time. You could decompose it into more than two. So there are actually many ways of decomposing functions.